Understanding the redundant switch and its role in satellite communication, Chapter 2. A redundant switch is a critical component in satellite communication systems. It ensures continuous operation by automatically switching to a backup LNB or buck in case of failure. This capability prevents signal loss and enhances system reliability. This diagram provides a step-by-step flow of signals from right to left, showing how we ensure signal receiving and transmission in a satellite communication system. Let's first examine how the system handles incoming signals. The incoming RF signal is captured by the antenna and directed through the OMT, orthomode transducer, feed. It then passes through the TRF, transmit-receive filter, which remove interference signals. After passing through the waveguide switch, the filtered signal is sent to one of the two low-noise block converters, LNB1 or LNB2. These LNBs amplify the weak satellite signal and convert it from a high-frequency RF signal to a lower intermediate frequency, IF, signal for further processing. To ensure continuous operation, a one-to-one redundant switch controller box is used to switch between LNB1 and LNB2 in case of failure. Finally, the processed signal travels through the RxIF cable to the modem for demodulation and further processing. Now, let's look at how the system handles outgoing transmissions. The modem proceeds IF signal and sends it through the TXIF cable to the redundant switch controller box. This controller box manages redundancy between buck 1 and buck 2, ensuring uninterrupted operation in case of failure. The selected block up converter, buck, amplifies the IF signal and converts it into an RF signal. The RF signal is then passed through the waveguide switch, which directs it towards the transmission path. The signal moves through the RRF to OMT feed, ensuring proper filtering before reaching the antenna. Finally, the antenna transmits the signal towards the satellite or the designated receiving station. Now, let's move to the power and control element in the diagram. AC power is supplied to the ODU, LNB, buck, and IDU, optional. In some cases, the power supply for the buck will be pre-integrated into the redundant switch system. Ethernet connections are used to monitor and control the ODU and IDU. If required, Ethernet also used between laptop and IDU if applicable. In summary, this system ensures a seamless and redundant signal flow for both transmission and reception, maintaining reliability and efficiency in satellite communication. The redundant components, such as the LNB and buck switches, play a crucial role in minimizing downtime and ensuring stable operation. LNBs and bucks are essential to ensure continuous operation of transmitting and receiving signals. The redundant switch provides a backup mechanism for these components, ensuring minimal downtime and signal stability. In a one-to-one system, one active and one standby LNB are managed. While in a one-to-two system, two active LNBs and one standby LNB are constantly monitored. Here are the four main benefits for using RSW in satellite communications. First, RSW prevents signal loss during component failures. In the world of satellite communications, even a brief interruption can have significant consequences. RSW ensures that the signal remains intact, even if a component fails, keeping your system running smoothly. Second, RSW increases system reliability in critical applications. Whether it's for defense, broadcasting, or global communications, RSW guarantees that your system stays operational, minimizing the risk of unexpected downtime. Third, it reduces maintenance and downtime costs. By utilizing RSW, you can eliminate the need for costly repairs or extended service interruptions. This leads to lower maintenance expenses and higher efficiency. Finally, RSW ensures seamless switching between active and standby units. In the event of a failure, the system automatically switches to backup units without any disruption, keeping your operations uninterrupted. In summary, RSW helps maintain reliable, cost-effective, and uninterrupted communication, ensuring your satellite systems always perform at their best.